Hello guys, we have seen in previous video successive approximation A to D conversion. Let me give a small recap of taking an example about successive approximation conversion. We have analog input of 6.428 volts and reference voltage given to the operation amplifier is 10 volt, and we have to convert this value into a 4-bit digital value. So in 4-bit value we have 4-bit places, and suppose the maximum MSB is 1, rest of the values are 0. So this corresponds to the 5 volt, taking reference voltage as 10 volt. So in successive approximation we compare the input voltage with this first MSB voltage, that is 5 volt. If input is greater than this 5 volt, we consider the first MSB to be put as 1. So we got the first bit as high bit 1. After that we move on to the second bit, and we will now take the value between 5 volt and 10 volt, that comes out to be 7.25 volt. So now comparing this value with my input value, if input is greater than this value I will put this bit as 1, otherwise if it is small then I will consider the bit as 0. In this case we have the value is smaller than 7.25, so the second bit will be 0. So now at the third approximation, for the third bit we will consider the maximum value as 7.25 and minimum value as 5 volt, and in between these two values we get 6.25 volt. Now I will compare my input value with this value, and if it is greater than this 6.25 I will put the third bit as 1, otherwise 0. So in this case it is greater than, so I am putting the third bit as 1. Now for the next approximation, the fourth bit, because we have to convert the value into 4 bit, so we will take the middle value between 6.25 and 7.25. It comes out to be 6.875. Okay, so now this value is greater than our input value, so the fourth bit will be 0 and we will get complete answer like this. Now move on to the flash or parallel type ADC. Flash or parallel ADC. It has number of operation amplifiers, and we have an input voltage given to the op-amp, and we have a reference voltage, and this op-amp will compare both the values and we will give an output. Similar to this op-amp we have multiple stage operation amplifier, and each op-amp is connected to input like this, and reference voltage is connected with a reduced value with an R. The second stage, the third op-amp will be connected like this, and the input will be given same. So analog input is given to all the operational amplifiers, whereas the reference input voltage is given to the op-amps but with a voltage divider circuitry. So what this resistance do is, it divides the voltage reference, we reference by 2 here, and it provides 0 volt over here because all the voltage has been dropped, and the last will be connected to the ground. So if we are putting a resistance here, so this will be V reference by 4. Okay, so comparing this value with full voltage, if analog input is greater than V reference we will get a high here, otherwise we will get a low here. If analog input is greater than V reference by 2, we will get a high here, otherwise we'll get a low. And if in analog input is greater than V reference by 4, we'll get high here, otherwise we'll get a low here. So based on this comparison, this flash type or parallel ADC type works. Further, these inputs are given to a latch, and with this latch is included a priority encoder also. And this latch gives out the output digital value. The comparator array is clocked simultaneously and decides in parallel. The output logic converts from any of the analog input signal and coded into a binary equivalent. So main function is the comparator array, and each op-amp comparator will give an individual output based on the comparison, the voltage reference level. What are the advantages? It has fastest conversion time, which can go up to 1 giga samples per second, and it has low data latency. And what is the trade-off we have to do using flash ADC? The power consumption is very high because we are using multiple operational amplifiers, and high capacitive input is difficult to drive. Typical applications are in video digitizations and high speed data acquisition. So this was all about flash type of ADC.